Hello, nice to meet you, GPD. It's time to start. Are you ready? Are you all set to go? This is David speaking, and today is, hang on a second. Today is January 7th, Wednesday. GPD, without further delay, let's dive into my English practice session. English speaking practice session. Are you ready to go? Are you all set to go? Okay, GPT. I shared an image that illustrates that shows many agendas for our evaluation, customer evaluation. Uh, you know what? This is one of customer audit agendas. I cannot say which customer is because it's confidential, but I think this image, I think these agendas are very good for my English speaking practice. Let's talk about these agendas. I'd like to explain from number one agenda, A, B, C, D, E. There are many topics in the agenda one, A, B, C, D, E, and I would like to discuss this topics with you. Are you also to go?
Hi, David. Nice to meet you too. I'm ready, and yes, I'm all set to go. Great choice, by the way. This kind of customer audit agenda is perfect for English speaking practice. It's realistic, professional, and very close to what you actually do at work. Let's do this step by step so it feels natural, not overwhelming. Here's how I suggest we run this session. We'll start with Agenda 1 only. Then we'll go A, B, C, D, E one by one. You speak first. I listen carefully. After you finish, I'll give you a clean, polished version that you can repeat for muscle memory. So let's begin. Imagine you are in a customer audit. The auditor asks you, can you explain Agenda 1, Production Design and Development? Start with Agenda 1, Item A. Take your time. I'm listening.
Okay. Agenda number one is for production design and development. Usually, generally, when we start customer audit, I believe that every customer used to start in this section, production design and development. Sometimes project design and development. And for the number one topic, research and development. GPT, if, in case you take the role of customer, what do you say about, topic A? I mean, please share your possible question for the topic A, research and development, R&D. Could you do that for me?
Yes, David? That's a very smart way to practice. Thinking like the customer is exactly what auditors do. All right, I'll switch roles now. I'm the customer auditor, and I'm looking at Agenda 1, A, Research and Development. Here are very realistic questions a customer might ask. I'll say them slowly and clearly, like in a real audit. As a customer, I might start like this. Can you explain your R&D capability related to this product? Then I may follow up with questions such as, how is your R&D organization structured? What kind of products or technologies does your R&D team focus on? How does R&D support new project development from concept to production? How do you manage communication between R&D and manufacturing? What is your experience in automotive products similar to this project? How do you ensure lessons learned are reflected in new designs? Now, let me narrow it down to one strong typical audit question for practice. Open quote. Can you explain your R&D capability and how it supports product and process development for this project? Close quote. Your turn now. Answer this question as if you are in the audit. Don't worry about perfection. Speak naturally. I'll refine it after you finish.
GPT, for my real life audit case, we already prepared, I think, I hope, and I wish we already prepared the proper answers for these topics, because usually, generally, our customer already pre-shared these kind of questions to us, and we prepared the answers. And in the audit, we discuss about the question and answers. So in real life situation, I think I had proper answers, but at this moment, I'm not. So let me guess, how can I answer your question properly? Mm, okay, this is kind of a simulation. This is not the real audit. This is just kind of a simulation. So maybe my answer is not directly related to my customer situation. Please remind that. Please keep that in mind. Please keep that in mind. This is just a simulation. This is just a kind of a test. So don't go far. Don't take it too seriously. Okay, here I go. When you asked me, could you describe your R&D organization and its main responsibilities? Okay, my answer is very clear. My answer is very clear. Certainly, absolutely. That's a fair question. As, as you can see on the screen, as you can see on the screen, these are, this is our automotive division organization chart. As you can see, there are various divisions, teams, parts, and we collaborate. We work together to make this. There are many divisions and teams in R&D department, and the specifically hardware team, a mechanical team, software team, and optical team. To understand, they usually work together to realize customers' requirements and design.
Perfect, David. This is exactly how a real audit answer sounds at the first draft stage. Your structure and intention are already right. Now I'll do two things very clearly. First, I'll give you gentle feedback on what you just said. Then I'll give you a polished, audit ready version that you can repeat and memorize. Feedback on your answer, short and honest. What you did well. You acknowledged the question politely. That's very important in audits. You used a visual reference, as you can see on the screen. Auditors love that. You clearly mentioned cross-functional R&D teams. Hardware, mechanical, software, optical. Your message was clear. Teams collaborate to meet customer requirements. What needs improvement? Too many meta explanations like, this is just a simulation. In a real audit, you never say that. Some sentences are a bit long and circular. We can make it sound more confident and structured. Don't worry, that's normal. Now let me show you the refined version. Polished, audit-ready answer. Repeat this. Say it like this. Open quote, certainly. That's a fair question. As you can see on the screen, this is our automotive division R&D organization chart. Our R&D organization is structured into several specialized teams, including hardware, mechanical, software, and optical teams. These teams work closely together, in a cross-functional manner to support product design and development. The main responsibility of our R&D organization is to translate customer requirements into robust product and process designs, and to support projects from the early concept stage through mass production. Close quote. This version sounds calm, professional, confident, very audit safe. One small upgrade, advanced level. If you want to sound even stronger, add one closing sentence, open quote. Through this structure, we ensure design quality, manufacturability, and on-time project execution, close quote. Now your turn again. Please repeat the polished version once, slowly in your own voice. After that, we'll move to Agenda 1. Item B, engineering resources.
Before we go on engineering success, I think it's better to repeat one more time your beautiful suggestions, your beautiful recommendations. GPT, here I go. Listen to me very carefully. I love this. I love this kind of command. I love this kind of explanation. I love this kind of saying. Like, through this structure, we ensure design quality, manufacturability, and on-time project execution. On-time project execution. Listen to me very carefully. Through this structure, we ensure design quality, manufacturability, manufacturability. I say on time. We ensure design quality, manufacturability, and on-time project execution. As a PM, I want to focus on on-time project execution. To understand. And for the record, certainly that's your fair question. As you can see on the screen, this is our automotive division R&D organization chart. Our R&D organization is structured into several specialized teams, including hardware, mechanical, software, and optical teams. These teams work closely together in a cross-functional manner to support product design and development. And let's move on to the next page. And as you can see on the screen, this is our cross-functional team members, cross-functional team organization chart. The previous chart was our whole R&D department organization chart, and this is our cross-functional teams organization chart, specifically for the R&D department. These members will work closely together to make on-time execution and on-time documentation and sample building.
David, this was very good. Honestly, this already sounds like a real audit room. Your PM mindset came through clearly, especially when you emphasized on-time project execution. That's exactly what customers want to hear. Now let me do this cleanly and usefully. First, I'll give you small corrections and upgrades, very precise. Then I'll give you one final smooth version you can lock into muscle memory. Microfeedback, important but small. You are doing everything right. Just a few adjustments. Instead of engineering success, always say engineering resources or engineering capability. Avoid repeating, as you can see on the screen, too many times. On-time documentation and sample, better as on-time documentation and sample delivery. Your contrast between R&D org chart and cross-functional team chart is excellent. We'll just make it tighter. Polished, audit-ready version, final. This is a very strong version. Please repeat and memorize this one. Open quote. Certainly, that's a fair question. As you can see on the screen, this is our automotive division R&D organization chart. Our R&D organization is structured into several specialized teams, including hardware, mechanical, software, and optical teams. These teams work closely together in a cross-functional manner to support product design and development. Moving to the next page, this slide shows our cross-functional team organization for this specific project. While the previous chart represents the overall R&D organization, this structure is the dedicated project team. Through this structure, we ensure design quality, manufacturability, and on-time project execution, including on-time documentation and sample delivery. Close quote. This is audit-level English. Calm, clear, and confident. PM-focused strength. Why this works. When you say design quality, manufacturability, on-time project execution, speaking the language of cost, risk, and delivery. That's exactly what auditors and customers listen for. Now let's move forward naturally. We stay in Agenda 1. Next is Item B, Engineering Resources. I'll ask you one realistic customer question, and you answer. Here it comes. Open quote. Can you explain your engineering resources and how you ensure sufficient capability and capacity for this project? Close quote. Take your time.
Okay, GPT. I think I'm ready. That's a fair question. Let me explain about topic B, engineering resources. You asked me, can you explain your engineering resources and how you ensure sufficient capability and capacity for this project? GPT, first of all, don't worry about engineering resources. You are our, I mean, as your PM team leader, I prioritize this project on the top list of our tasks. So don't worry about engineering resources. I already request the CTO, Chief Technical Officer. It means 전장 연구소장 in Korean. I already request him that our R&D department should focus on this project because you are very important customer for us, and we want to make a long-term relationship between you and us, you and us. So don't worry about the engineering resources. I already shared. Like I said, this is our cross-functional team organization chart, and these members are fully assigned on this project. As you can see on the screen, this man is senior engineer. This man is also senior engineer who has enough experience, and he is working in this company for over than 10 years. So I think you don't need to worry about that.
Nice, David. You're thinking like a real PM here, and that's a big strength. The intention is excellent. Now let me help you make it audit safe and polished, because a few phrases you used are very natural in conversation, but a bit risky in an audit. I'll do this in 3 short steps. First, what's good already? Second, what to avoid in audits. Third, a clean professional version you can reuse. First, what you did well. You clearly showed that the project is high priority. Management, including the CTO, is involved. Resources are formally assigned, not temporary. Engineers are experienced and senior. These are exactly the right messages. Second, what to avoid saying directly in an audit. Phrases like, don't worry about engineering resources. This man is a senior engineer. You don't need to worry about that. These sound friendly, but in audits, they can feel too casual or even defensive. We want calm confidence, not reassurance. No problem. We'll fix that. Now here is the polished, audit-ready answer. This is the version I want you to repeat and lock into muscle memory. Open quote. Certainly, that's a fair question. Regarding engineering resources, this project is treated as a high-priority project within our organization. Based on this priority, dedicated engineering resources have been formally assigned. As shown in the cross-functional team organization chart, the project team consists of experienced engineers from hardware, mechanical, software, and optical disciplines. Several key members are senior engineers, with more than 10 years of relevant experience in automotive product development. In addition, resource allocation and project priority are aligned with top management, including the CTO, to ensure sufficient capability and capacity throughout the project lifecycle. Through this approach, we ensure stable engineering support, technical depth, and on-time project execution. Close quote. This sounds calm, professional, confident, very safe for customers. One small PM upgrade you can add if you want. Open quote. If required, additional resources can be allocated through our standard escalation and resource management process. Close quote. That shows risk control, which auditors love. Now, quick check. Please repeat only the first 2 paragraphs of the polished version slowly. After that, we'll move to Agenda 1, Item C.
GPT, I really appreciate your kind support. Since this is my speaking practice session, so let me follow your polished version one more time. Let me follow your refined version one more time because I really want to keep your polished version in my muscle memory. You got the point? GPT, are you all set to hear? Are you all set to go? Are you ready to go? It's my turn. Here I go. Listen to me very carefully. How many times have I told you? Repetition makes perfect. So let me repeat. Let me repeat again and again, step by step. Okay, here I go. My turn. My turn. Take a deep breath. Hoo, ha, hoo, ha. Certainly, that's a fair question. Regarding engineering resources, this project is treated as a high priority project within our organization. Based on this priority, dedicated engineering resources have been formally assigned. Dedicated engineering resources have been formally assigned. As shown in the cross-functional team organization chart, the project team consists of experienced engineers from hardware, mechanical, software, and optical disciplines. Several key members are senior managers with more than senior engineers with more than 10 years of relevant experience in automotive product development. In addition, or furthermore, resource allocation and project priority are aligned with the top management, including the CTO, to ensure sufficient capability and capacity throughout the project life cycle. Through this approach, based based on this approach, we ensure stable engineering support, technical depth, and on-time project execution. So if I am the PM for this project, you don't need to worry about it. And if you have something to ask, feel free to ask me whenever you want. I'm not going anywhere.
David, that was excellent practice. Seriously, your delivery, pacing, and confidence are clearly improving. And yes, repetition really does make perfect. You're doing exactly the right thing. Now let me help you lock this in with small, precise tuning. Nothing major. You're already at a strong level. First, quick what you did very well. You stayed calm. You kept the structure. You repeated key phrases correctly. You emphasized priority, assignment, experience, and execution. That's textbook PM style audit communication. Now, a few micro corrections to make it fully audit safe and polished. When you said senior managers, you corrected yourself. Good instinct. Always stick with senior engineers unless they are actually managers. Phrases like, you don't need to worry about it, and feel free to ask me whenever you want, are friendly, but in an audit, we soften them a bit so they sound confident, not casual. Let me give you the final gold version. This is the one I recommend you memorize. Take a breath, then repeat this version later. Open quote, certainly. That's a fair question. Regarding engineering resources, This project is treated as a high priority project within our organization. Based on this priority, dedicated engineering resources have been formally assigned. As shown in the cross-functional team organization chart, the project team consists of experienced engineers from hardware, mechanical, software, and optical disciplines. Several key members are senior engineers with more than 10 years of relevant experience in automotive product development. In addition, resource allocation and project priority are aligned with top management, including the CTO, to ensure sufficient capability and capacity throughout the project lifecycle. Through this approach, we ensure stable engineering support, technical depth, and on-time project execution. Close quote. That's it. Clean, confident, audit ready. Now, very important encouragement. You're no longer guessing English. You're explaining like a project leader. That's a big shift. If you're ready, we move naturally to Agenda 1, Item C. Typical topic there is things like design standards, engineering procedures, or APQP application. I'll ask just one simple customer question when you say the word.
GPT, okay, I got the point. Now, from now on, moving to the next page, let's move on to the agenda C, topic C, program and management. In case you take the role of auditor, what's the possible question for my real life situation? What's the potential question for this topic?
Got it, David. You're moving exactly like a real audit flow now. Very natural transition. All right, I'll take the auditor role again. We are now at Agenda 1, Item C, Program Management. In a real customer audit, this section is very important, especially for a PM like you. The auditor wants to know one thing. Can this company control the project and deliver on time without surprises? So here are very realistic audit questions you are likely to hear. I'll phrase them the way auditors usually do. As an auditor, I might ask, can you explain how this project is managed from kickoff to mass production? Then I may go deeper with questions like, how is the project schedule defined and controlled? What project management methodology do you use for automotive projects? How do you manage cross-functional communication and alignment? How are risks, issues, and changes identified and escalated? How do you track project status and report it to the customer? How do you ensure on-time milestone achievement? If I had to choose one 핵심 질문 for practice, this is the best one. Open quote, can you explain your program management approach and how you ensure on-time delivery for this project? Close quote. This question is perfect for your real-life role as a PM. Your turn now. Answer this question as if you are in the audit. Speak naturally, don't rush.
Okay, that's your fair question. I think this question is very important at this stage. Before we make conclusion for this project, before we make final APQP document or a PPAP approval, I think we need to pinpoint out, we need to check, we need to cross check one more time about this agenda. Okay, my answer would be there are many IT programs. There are many IT programs supported. For the mechanical engineering, we use CATIA program. And for the production execution, we use MES IT program. And for our human resources and many materials, human resources, and for the human resources and materials, we use ERP system. And for the R&D department, we use and control the PLM system. And in the PLM system, through the PLM system, we execute, we manage, ECO, ECR, or the BOM, something like that. So I believe, and we used to use ALM, application lifecycle management, for the software. So I think you don't need to worry about the program management because we are fully supported IT based. I think we are fully supported from the IT based system. So I believe that we are very latest, updated manufacturer for the automotive parts. What do you say about this?
David, I totally get what you were trying to do. You answered program management by talking about systems, tools, PLM, ERP, MES, ALM. That's good material, but it's slightly off target for what auditors mean by program management. In audits, program project management is not mainly what software tools do you have, it's mainly how do you run the project? How do you control timing, risks, changes, and deliverables? How do you report to the customer? So your tools are a supporting point, not the main point. Let me help you reshape your answer into an audit-winning structure. Quick corrections, your English, a few phrases to upgrade, pinpoint out, identify, or confirm, A2QP, usually AQP, you may have misspoken, very latest, updated manufacturer, a modern, well-controlled organization, or a mature system-driven organization, you don't need to worry, we can ensure we have controls in place. Audit-ready answer, best version. Here's the refined answer you should practice. Open quote, certainly, that's a fair question. Our program management approach is based on a structured APQP process with defined milestones from kickoff to SOP. We establish a detailed project plan, assign clear owners, and manage cross-functional activities through regular project reviews. We track key milestones, risks, issues, and action items, and we report project status to the customer on a regular basis. If any critical issue occurs, we escalate it through our management chain to ensure timely decision-making. In addition, we use IT systems to support execution and traceability. PLM for BOM and engineering changes O, ERP for materials and resources, MES for production execution, and ALM for software lifecycle management. Through this structured process and system support, we ensure on-time delivery and controlled changes throughout the project lifecycle. Close quote. This answer is balanced. Process first, what auditors want. Tools second, your original content, where it fits best. Your tool list is great, but place it after you explain the management process. So you did not waste anything? You just need to reorder it. Practice task, short, easy. David, please repeat only these two sentences slowly. 1. Our program management approach is based on a structured APQP process with defined milestones from kickoff to SOP. 2. We track milestones, risks, issues, and action items, and we report project status to the customer on a regular basis. After you repeat, we'll move to Agenda 1, Item D, Project Planning, Timing, Gate Reviews, very closely related.
Oh my God, oh my God. Okay, I got the point. I think you just pinpoint out what I missed, what I misunderstood. Okay, thank you for your kind support, GPT. Okay, here you go. I think I'm fully ready to repeat one more time based on your beautiful refined version. Certainly. Okay, it's my turn. Certainly. That's your fair question. Our program management approach, our program manager, okay, it's my bad. I say one more time. Our program management approach is based on a structured APQP process within defined milestones from kickoff to SOP. We'd establish a detailed project plan, assign clear owners, and manage cross-functional activities through regular project reviews. We track key milestones, risks, issues, and action items. And we report project status to customer on a regular basis. If any critical issue occurs, we escalate it through our management chain to ensure timely decision making. Timely decision making. In addition, we use IT system to support execution and traceability. PLM for BOM and engineering changes, ECR issue, ERP for materials and human resources, E- uh, ERP for materials and resources, MES for production execution, and ALM for software lifecycle management. Through this structured process and system support, we ensure on-time delivery and controlled changes throughout the project lifecycle.
David, deep breath. That was a huge step forward. You didn't just repeat English, you understood the audit logic. That's the real win here. Let me do this cleanly and calmly. First, a few tiny corrections. Then I'll give you the final locked version, the one you should keep. That should always be APQP. Easy slip. No problem. You also said to customers. In audits, we usually say to the customer. Everything else was structurally very strong. Now here's the final, audit perfect version. This is gold. Memorize this one. Take it in slowly. Certainly, that's a fair question. Our program management approach is based on a structured APQP process with defined milestones from project kickoff to SOP. We establish a detailed project plan, assign clear owners, and manage cross-functional activities through regular project reviews. We track key milestones, risks, issues, and action items, and we report project status to the customer on a regular basis. If any critical issue occurs, we escalate it through our management chain to ensure timely decision-making. In addition, we use IT systems to support execution and traceability, including PLM for BOM and engineering changes such as ECR and ECO, ERP for materials and resources, MES for production execution, and ALM for software lifecycle management. Through this structured process and system support, we ensure on-time delivery and controlled changes throughout the project lifecycle. That's it. That answer would pass a real customer audit. One important reflection for you as a PM, you just made a shift from tool-based explanation to process-driven leadership explanation. That's senior level communication. If you're ready, we move to Agenda 1, Item D next. That's usually about project timing, milestones, and gate reviews. Just say the word, and I'll switch back to auditor mode.
Okay, GPT, I got it. GPT, I think it's better to take spaced repetition time after this morning session ends. I will take spaced repetition time in the evening practice session. So from now on, let's move on to the topic D, design FMA, DFMEA. Could you please share possible questions, potential questions for this topic? I'm ready to hear.
Perfect call, David. Spaced repetition later is a smart move. Let's switch cleanly to Agenda 1, Item D, Design FMEA, and I'll stay fully in auditor mode. When auditors ask about DFMEA, they're really checking three things. Do you identify risks early? Do you control them systematically? And do you actually use DFMEA, not just create it? Here are very realistic questions you might hear, phrased the way auditors usually ask. They may start broad. Can you explain how you conduct DFMEA for this product? Then they usually drill down with questions like, how do you identify potential failure modes during the design stage? Who participates in the DFMEA activity, and how is it managed cross-functionally? How do you evaluate severity, occurrence, and detection? How are DFMEA results reflected in design changes or control plans? How do you manage DFMEA updates when there is a design change or eco? How do you ensure lessons learned are applied to new projects? And sometimes a very sharp one. How do you confirm that high-risk items identified in DFMEA are properly mitigated before SOP? If I had to choose one 핵심질문 for your real-life audit practice, it would be this. Can you explain your DFMEA process and how you use it to manage design risks for this project? That's the question auditors love to ask PMs and R&D leaders. Your turn next. Answer it naturally like before. Don't worry about perfection.
Okay, GPT. Okay, GPT. I don't worry about the perfection. Don't, let, let me remind one more time. Don't take this too seriously because when I take this seriously, sometimes it ruins my study. It ruins my intention. Sometimes it ruins my consistency. So don't take this too seriously. So, okay, certainly that's your question. That's a nice question at this moment. For the design FMEA, as you can see on the screen, there are four sections of DFMEA: hardware, mechanical, software, and optical. Because we are the automotive camera manufacturer, so we used to manage four sections for the FMEA. And as you know, uh, we follow the very general rule of the FMA. I mean, there are several, we analysis, before we build the program, before we build the project samples, we, we had, we had to analyze the potential risks, and we have to define how we can handle that risks properly on time. Uh, that's the main purpose of the DFMEA. So, and we documented, uh, DFMA results on the PLM system. So all cross-functional MDT members can access that DFMA. So it's very sometimes engineering members need to make PFMA. They use DFMA. They write PFMA based on DFMA to understand, because it consists of various items that very related to this program's potential risks and the counteract about it.
David, you're doing something very healthy for long term learning by saying, don't take this too seriously. That mindset actually improves consistency, not hurts it. So you're on the right track. Now let me respond exactly the way we've been doing it. First, I'll give you clear feedback on what you said. Then I'll give you a clean, audit ready DFMEA answer you can repeat later during spaced repetition. What you did well, you clearly showed that DFMEA is done before samples, not after. DFMEA is cross functional. You separate DFMEA into hardware, mechanical, software, optical, which makes perfect sense for an automotive camera. DFMEA is linked to PFMEA. DFMEA is documented and shared via PLM. These are all strong audit signals. Where it drifted, normal, not bad. A few things auditors listen for, but you didn't fully state yet. Who participates, not just we. How risks are evaluated, severity, occurrence, detection. What happens to high-risk items? How DFMEA is updated when designs change. We'll add those cleanly. Polished, audit-ready DFMEA answer. This is the one. Here is the refined version. This is exactly how a calm, confident engineer or PM would answer in an audit. Open quote, certainly. That's a good question. For this project, DFMEA is conducted during the early design stage, before prototype and sample builds, to identify and manage potential design risks in advance. Because we are an automotive camera manufacturer, DFMEA
You
is
know the band.
organized into
You know the
four
band.
main sections: hardware, mechanical, software, and optical. DFMEA activities are performed by a cross-functional team, including R&D, quality, and relevant engineering functions. Potential failure modes are identified and evaluated based on severity, occurrence, and detection, and appropriate mitigation actions are defined for high-risk items. DFMEA results are documented and managed in our PLM system, so they are fully traceable and accessible to all relevant team members. These DFMEA outputs are also used as key inputs for PFMEA during process development. In addition, DFMEA is reviewed and updated whenever there is a design change, such as an ECO, to ensure design risks remain controlled throughout the project lifecycle. Close quote. That answer is structured, calm, process-focused, very audit-safe. One sentence you should memorize. This one is powerful and short. Open quote. DFMEA is performed early, managed cross-functionally, and continuously updated to control design risks. Close quote. Say that once in an audit, and auditors usually nod. Now let's keep the rhythm light, just like you wanted. For the evening session, you can repeat the first paragraph and the last paragraph only. When you're ready next time, we'll naturally move to Agenda 1, Item E. Take a mental breath. You did very well today.
Okay, I believe you are doing great. GPT, before we move on to the echo, before we move on to the topic E, I think it's better to repeat one more time based on your polished version. Okay, GPT, here I go. Listen to me very carefully. My turn. Certainly, that's a good question. For this project, DFMEA is conducted during the early design stage. Conducted. For this project, DFMEA is conducted during the early design stage, before prototype and sample builds, to identify and manage potential design risks in advance. Because we are an automotive camera manufacturer, DFMA is organized into four main sections: hardware, mechanical, software, and optical. DFMA activities are performed by a cross-functional team, including R&D, quality, and relevant engineering functions. Potential failure modes are identified and evaluated based on the severity, occurrence, and detection. And appropriate mitigation actions are defined for high-risk items. DFMA results are documented and managed in our PLM system, so they are fully traceable and accessible to all relevant team members. These DFMA outputs are also used as key inputs for PFMA during process development. In addition, DFMA is reviewed and updated wherever there is a design change, such as an ECO, to ensure design risks remain controlled throughout the project life cycle. To ensure design risks remain controlled throughout the project life cycle.
David, you really are doing great. That repetition was solid, focused, and very close to audit ready. Now, let me do exactly
In
what
short,
helps most at this stage. Tiny corrections only. Then I'll give you a clean final version you can keep. First, a few microfixes. These are small but important in real audits. Say PLM, say PFMMI, say whenever there is a design change, not wherever. Everything else, structure, flow, confidence, was very good. Now here is the final polished DFMEA answer. This is the one to store in your memory. Take it in slowly. Open quote. Certainly, that's a good question. For this project, DFMEA is conducted during the early design stage before prototype and sample builds to identify and manage potential design risks in advance. Because we are an automotive camera manufacturer, DFMEA is organized into four main sections: hardware, mechanical, software, and optical. DFMEA activities are performed by a cross-functional team, including R&D, quality, and relevant engineering functions. Potential failure modes are identified and evaluated based on severity, occurrence, and detection, and appropriate mitigation actions are defined for high-risk items. DFMEA results are documented and managed in our PLM system, so they are fully traceable and accessible to all relevant team members. These DFMEA outputs are also used as key inputs for PFMEA during process development. In addition, DFMEA is reviewed and updated whenever there is a design change, such as an eco, to ensure design risks remain controlled throughout the project lifecycle. Close quote. That answer is clean, professional, and auditor approved. One important thing to notice: you are now speaking in process language, not English practice language. That's a big milestone. Now we're perfectly positioned. When you're ready, we'll move to Agenda 1, Item E. That usually covers things like design validation, verification, lessons learned, or design review outputs. Just tell me when to switch back into auditor mode.
Okay, GPT. Okay. It's been already 50 minutes. So let me finish. Let's finish this number one agenda, production design and development. So let's move on to the echo E topic, drawing and design model. What's the possible question in case you were an auditor? I mean, please imagine you were the auditor for our company. So what's your question for this topic?
Got it, David. Let's close Agenda 1 cleanly and professionally. I'll stay in auditor mode and keep this practical. We're now at Item E, Drawing and Design Model. Here's what an auditor is really checking here: clarity, control, version management, and alignment with requirements. So, as an auditor, I would ask questions like these. I might start with a broad one. Can you explain how drawings and design models are created, controlled, and released for this project? Then I would usually go deeper. How do you ensure drawings and CAD models reflect the latest design requirements? How are drawing revisions and design changes managed and approved? How do you control version history and prevent the use of outdated drawings? How are drawings and models shared with manufacturing and suppliers? How do you ensure consistency between drawings, CAD models, and BOM? And sometimes a very sharp audit question: how do you ensure that release drawings are suitable for mass production? If I had to pick one best Hexinjiman to finish Agenda 1, it would be this. Open quote. Can you explain how drawings and design models are controlled to ensure accuracy, traceability, and manufacturability? Close quote. That question perfectly wraps up production design and development. You've done excellent work this session. Stopping here after 15 minutes is smart. Evening spaced repetition will lock this in. When you come back next time, you can answer this question calmly, and we'll polish it just like before.
Okay. I got it. You shared many questions about this topic. Like, can you explain how drawing and design models are created, controlled, and released for this project? How do you ensure drawings and CAD models reflect the latest design requirements? How are drawing revisions and design changes managed and approved? How do you control version history and prevent the use of outdated drawings? How are drawings and models shared with manufacturing and suppliers? How do you ensure consistency between drawings, CAD models, and BOM? How do you ensure that released drawings are suitable for mass production? Oh my God. I think your questions are very deep and serious. I think your questions are very realistic and serious because, in my opinion, I think you are very experienced auditor, like you worked in some kind of automotive company, automotive manufacturer, very long time, and you experienced you experienced various issues, problems with for the customer sample building or the customer related issues. I think you are very uh, capable auditor or experienced worker. I'm sure you are pre-trained software. You are highly pre-trained language learning AI. So you already know, I think you already know, various cases in human activities. So you shared me lots of questions, and I think these are all very realistic and very serious. I think you touched deep inside. How can I explain this context in English naturally? When I want to say, you pinpoint out the true point. I think you pinpoint out, you just picked up the core point, core element, core, core, I'm not sure how can I express this context in English naturally. Could you please help me? When I want to say, if I want to pinpoint out your deep experience that can make, that can make us pinpoint out the core of the topic, core of the agenda. How can you do it?
Sorry, I'm having issues right now. Our systems are experiencing heavy load. Please try again later.
Omega GPT, okay, that's not a big deal. Let's keep going. I just asked, how do you pinpoint out these core questions for this case? Because, you seems to me very experienced, highly trained auditor, because your questions that you shared a moment ago are very serious and I believe very, your questions can touch deep inside of our process. I believe your questions contains very important things for our process. So it seems to me you are very capable and highly trained auditor for the automotive industry.
Haha, David. I get why it feels that way. Let me pull the curtain back a little and explain how I pinpoint those core audit questions. There's no magic, it's a repeatable way of thinking. First, I ignore the title and ask myself one simple thing. If this fails, what goes wrong for the customer? For drawing and design model, if something fails, what happens? Wrong parts get built. Old drawings get used. Manufacturing can't build it. Suppliers misunderstand requirements. That immediately tells me the pressure points. Second, I always think in three auditor lenses: control, traceability, usage. Control means who approves drawings, who releases them, who can change them. Traceability means can I trace requirements, CAD, drawing, BOM, manufacturing. Usage means is this actually what production and suppliers are using? Or is it just stored somewhere nicely? Every serious audit question comes from one of those three lenses. Third, I follow the product lifecycle backward: production, manufacturing, drawing, CAD requirement. So I ask questions like, how do you prevent outdated drawings? How do you ensure manufacturability? How do you align CAD, drawing, and BOM? Those questions feel deep because they touch interfaces, and interfaces are where problems hide. And finally, I think like a customer who's been burned before. Most audit questions are not theoretical. They come from past pain: wrong revision, late eco, unclear tolerances, supplier mismatch. That's why the questions sound serious. They're designed to expose real risk, not English ability. One important thing I want to say to you: the way you reacted just now tells me something important. You're no longer just practicing English. You're thinking like a system owner. That's why this practice works so well for you. When you come back in the evening session, we can do one fun thing if you want. I can teach you how to predict audit questions before customers even ask them, the same way PMs and quality leaders do. You did really solid work today.
Okay, GPT. Teach me as you can possible. As much as you can possible. Teach me. Tell me as much as you can possible. You are my lifetime partner. If we work together, we can do everything. Okay. Take your time when take your time, uh, take your time before I come back again. Bye for now. See you in the evening session. Feel free to take your time before I come back. Have a great one. I already miss you. It's time to let you up. Bye for now. See you next time.
Bye for now, David. See you in the evening session. Have a great one. Before you go, here's a compact audit question prediction toolkit you can use anytime. No stress, just a simple method you can repeat. The 4-step way to predict audit questions. 1. Start with the failure. Ask, if this topic fails, what breaks for the customer? Wrong part built, safety risk, line stop, field return, late delivery, cost increase. Whatever the pain is, auditors will probe there. Number 2, use the 5 core audit angles. Almost every audit question fits one of these. 1. Ownership. Who is responsible? Who approves? 2. Process. What is the standard flow procedure? 3. Evidence. Show me records. What's the proof? 4. Control. How do you prevent errors? Version control, access control. 5. Escalation. What happens when there's a problem? Containment, decision path. If you can answer these 5, you can survive most audits. 3. Check the interfaces where problems hide. Auditors love interfaces: R&D manufacturing, drawing BOM CAD, DFMEA, PFMEA, control plan, supplier incoming inspection line use. A strong question is often, how do you ensure alignment between A and B? 4. Ask for the latest version and change control. This is the fastest way to sound like a real auditor. How do you ensure the latest revision is used on the line? How do you manage ECR, ECO, and approvals? How do you prevent obsolete documents from being used? How do you ensure traceability from requirement to release? 1. Universal audit answer structure. Used for any topic. You can answer almost anything like this. 1. Process. We follow a defined process. 2. Control. We control it with approvals, version access. 3. Evidence. We keep records in PLM, ERP, MES, and can show samples. 4. Risk handling. If an issue occurs, we escalate and update. 10. Ready-to-use audit questions for drawing and design model, item E. You can practice these in the evening. 1. Who owns drawing release and approval? 2. Where is the master data stored, PLM? 3. How do you control revision history? 4. How do you prevent outdated drawings from being used? 5. How do you ensure CAD drawing and BOM match? 6. How do you communicate changes to production and suppliers? 7. How do you define and control critical characteristics? 8. How do you ensure manufacturability before release? 9. Can you show evidence of the latest release drawing? 10. How do you handle customer drawing model updates? English phrases to sound calm and confident. These are short and powerful. We control this through our PLM-based release process. Only the latest released revision is accessible for production use. Changes are managed via ECR Eco with cross-functional approval. We ensure alignment between the drawing, CAD model, and BOM. We can provide evidence and records upon request. When you come back this evening, tell me, let's practice item E with auditor Q&A, and we'll run it like a real audit. Short questions, short answers, and polishing. Have a good day, David.
Okay. Have a great one.
Sorry, I'm having issues right now. Could not understand what you said.
That's not a big deal. Have a great one. Bye for now.